Welcome to This Explainer. So today we're diving into a really fascinating mystery. Why is it that we can so easily forget where we put our car keys this morning, but we vividly, almost agonizingly, remember exactly how someone made us feel years ago? It's a totally universal human experience, right? You can completely forget a math formula you spent weeks studying for, but the sting of a specific rejection or a sudden loss, that stays with you, crystal clear. Well, today we're going to unpack the biological mechanics behind why that actually happens. And it really all comes down to this one absolutely crucial realization. The brain just doesn't store emotional pain the same way it stores normal memories. I think we often picture our memory as this single hard drive, right? Like a unified system where everything, from your grocery list to your deepest heartbreak, just gets saved in the exact same folder. But that is completely false. Our minds literally use an entirely different biological system for our deepest wounds compared to our everyday factual memories. Section 1. Factual versus emotional memory. Okay, so think of factual memory as a totally neutral filing cabinet. It's where you store the capital of France or, what you had for breakfast last Tuesday. It's mundane, it's objective, and quite frankly, it's easily forgotten because your brain doesn't really deem it critical to your survival. Emotional memory, on the other hand, that is a blaring survival alarm system. It is deeply encoded and specifically designed for vivid, instantaneous recall. When an event carries a massive emotional charge, like intense fear, shame, or grief, your brain just entirely bypasses the standard filing cabinet. It flags the event in bright red ink. Moving right along to Section 2, why trauma lasts longer. To really understand the mechanics here, we need to meet the key players inside your brain, starting with the amygdala. Think of the amygdala as your brain's emotional threat detection center. It's essentially a smoke detector that is just constantly scanning your environment for danger. When we experience emotional pain, the amygdala fires up immediately. And here's the thing. It doesn't pause to analyze the logic of the situation. It just screams threat detected, whether you are facing a literal physical danger or a devastating emotional blow. Next up, we have the hippocampus. This is your brain's memory sorting and storage facility. Think of it as your internal archivist. Normally, the hippocampus just calmly takes in the events of your day, timestamps them, and neatly files them away in that neutral filing cabinet we just talked about. But when the amygdala smoke detector is blaring, it sends emergency signals straight to the hippocampus. Under this perceived threat, the hippocampus stops its normal cataloging and instead stamps the incoming memory as absolutely critical for your survival. And here is where the memory gets permanently sealed. The brain releases cortisol, which is a major stress hormone. In this context, cortisol acts like neurological superglue. It washes over those neural pathways, basically locking that emotionally charged, painful memory deep into your brain's architecture. This trio, the amygdala sounding the alarm, the hippocampus marking it as a priority, and cortisol gluing the whole shebang together, is exactly why you can recall an emotional wound with such intense, visceral detail even decades later. Which brings us to Section 3, the brain's survival mechanism. So it's really important to understand that this lingering trauma isn't a defect in your brain. Actually, emotional pain is an evolutionary survival mechanism designed specifically to protect us from future harm. Look, our ancient ancestors didn't survive by remembering nice sunsets, right? They survived by intensely remembering the bush where the tiger was hiding or the berries that made them violently ill. Your brain holds on to emotional pain to create a map of what hurts so you can avoid it in the future. It is an evolutionary engine built to keep you safe from experiencing that exact same threat again. It's just that today, the threat is rarely a tiger. It's more often a toxic relationship or a really painful failure. But your brain's biology, it treats it with the exact same life or death intensity. Let's look at Section 4. Can memories be rewritten? So we have to ask ourselves the million-dollar question. If our biology is designed to superglue these memories into our heads, are we just permanently stuck with these painful alarms? Or can emotional memories actually be rewritten? The incredible truth here is that memories are reconstructive events. They are not permanent, read-only files. Just let that sink in for a second. Most of us imagine our memories are kind of like a video recording that we just press play on, but neuroscience tells us something completely different. Every single time you recall a memory, you aren't just pulling up a permanent locked file. You are actually reconstructing it from scratch in your mind. It's honestly more like a Wikipedia page than a carved stone tablet. And because you are actively rebuilding the memory every time you think about it, the memory becomes momentarily unstable. It becomes vulnerable to edits and changes. Now for Section 5, Healing through Neuroplasticity. Before we talk about the specific steps to heal, we really need to understand neuroplasticity. This is the brain's ability to reorganize itself by forming new neural connections throughout life. For a really long time, scientists thought that once you reached adulthood, your brain was just fixed, hardwired, and entirely unchangeable. But neuroplasticity proves that our brains are highly malleable. They're basically like plastic. This means that the neural pathways carved by cortisol and trauma are not set in stone at all. Your brain is capable of immense structural healing over time. So how do we actually use this to heal? Well, it's by following a process known as memory reconsolidation, which breaks down into these 3 steps. Step 1, you recall the traumatic memory. You literally bring it out of the filing cabinet and onto the workbench, which makes it reconstructive and vulnerable. Step 2 is the magic key. You introduce a new context of safety or a different emotion. This is very often done in therapy, where you recall a painful event while sitting in a safe, calm environment, guided by a professional. You are essentially pairing the old painful memory with a brand new feeling of safety. And then step 3, the brain reconsolidates the memory. When you put the memory away this time, it gets saved with that new, softened emotional context. So you don't forget the facts of what happened, but you physically rewrite the memory, lowering the volume on that blaring survival alarm. Which brings us to the end of our journey in this explainer today. We've gone all the way from the rigid superglue of cortisol to the incredible moldable hope of neuroplasticity. I want to leave you with this provocative thought. If your brain literally has the power to rewrite its past pain, what does your future look like? You are not permanently trapped by your brain's ancient chemistry. You have the biological capacity to soften your deepest wounds. So, how will you use neuroplasticity to shape your own healing? Think about that as you go about your day. Thanks for joining me, and keep learning.